Welcome to The Hidden Layer. Today, we're diving into a paper that's a real game changer. It's not just about building a smarter AI, it's about building an AI that can build itself and do it better. Let's get right into it.
So let's start with a big question, one that's felt like science fiction for decades. Can AI actually speed up its own development? Well, what if I told you it's not science fiction anymore? It's happening right now. There's a new system out there that's not just, solving problems. It's actively making itself smarter, faster.
Take a look at this number, plus 12.5 points. Right now, it's just a number on a screen. But trust me, by the end of this explainer, you'll see why this single result is such a massive deal for the future of artificial intelligence. Over the next few minutes, we're going to break down exactly how this new AI framework is pulling this off. We'll look at the incredible results it's already getting. And most importantly for you, we're going to pull out the core ideas that you, as an applied engineer, can use to build more systematic and verifiable AI agents. Oh, and you're definitely going to want to stick around because toward the end, I'll reveal the 2 secret ingredients that really make this whole system tick. These are the key things that set it apart from pretty much every other AI agent out there. All right, so first things first. To really get why this new framework is so important, we have to talk about the huge problem it's built to solve, and that is the research bottleneck in AI. You see, making real breakthroughs in AI isn't like flipping a switch. It's actually kind of slow. It's super expensive. And here's the kicker. It relies so much on human intuition. You've got brilliant researchers making educated guesses, testing them out, and basically just hoping for the best. The paper calls this weakly supervised research loops, which is a fancy way of saying it's trial and error on a massive scale. And that right there is the big bottleneck. So, the big question is, how do you break that bottleneck? Well, this paper introduces a solution called the ASI-Evolve framework. And honestly, it's a completely new way of thinking about how we do AI research. So what is it? Put simply, ASI-Evolve is a system designed to automate the process of AI discovery. Think of it less like a tool and more like an AI research assistant, an agent that can go off and work on its own. So instead of a human guessing and testing over and over, this framework does it systematically. It's trying to turn research from an art form based on intuition into a repeatable science. And this is the core of how it works. It's a simple but really powerful 4-step loop. First, the agent learns from all the existing knowledge it can find. Then, it uses that to design new ideas, new architectures, new algorithms. After that, it runs experiments to test those designs out. And finally, and this part is absolutely crucial, it analyzes the results to figure out what to learn next. Learn, design, experiment, analyze. It's a closed loop for AI discovery. Okay, but a framework is just a theory on paper until you see the results, right? So let's look at what actually happened when the researchers let ASI-Evolve loose on some of the toughest problems in AI development today. So get this, in the area of neural architecture design, which is kind of like creating the blueprint for an AI's brain, the system didn't just find 1 or 2 little improvements. It discovered 105 brand new state-of-the-art architectures. I mean, just to put that in perspective, a single one of those discoveries from a human team would be a huge deal. The system did it over 100 times. And the improvements didn't stop there. Let's talk about data curation. Picking the absolute best data to train a model on. It's super important. The data pipeline that ASI-Evolve designed by itself boosted performance by almost 4 points on average. That is a massive gain, and it got there just by being smarter about the data it was using. Okay, now for the results that are, frankly, mind-blowing. These are on some of the toughest benchmarks out there. Remember that plus 12.5 points I showed you at the very beginning? That was its score boost on AMC32, a seriously hard math competition. It did almost the same thing on another math benchmark, AME24. And get this, on MMLU, a huge reasoning test, it jumped up by 18 points. We're not talking about tiny little tweaks here. These are gigantic leaps forward. So you have to be wondering, how is it doing this? What makes ASI-Evolve so much better than anything that's come before? Well, that brings us to those 2 secret ingredients I promised you at the start. First, you've got to understand that most AI agents are really good at tasks where they get quick, clear feedback, like winning a video game. But scientific research, that's a totally different ballgame. It's a long, complicated process where the feedback from one experiment might take weeks and be super hard to understand. ASI-Evolve was built from the ground up for this messy real-world research environment. And here is secret ingredient number 1, the cognition base. The best way to think about this is like the system's own personal library and its institutional memory. So instead of starting from a blank slate every single time, the agent gets a huge injection of accumulated human knowledge, all the insights, past papers, and old experiment results. It's not about replacing human intuition, it's about systematizing it and building on top of it. Now for the second secret ingredient, the dedicated analyzer. This is the component that truly closes that discovery loop we talked about. After any experiment, the analyzer's one and only job is to figure out why it worked or why it failed, and then boil that down into a simple, reusable insight. And this is so important. It means no experiment is ever wasted. Every single result, good or bad, makes the entire system smarter for the next cycle. Okay, this is all incredibly cool, but let's bring it back to the real world. How can you, as an engineer building AI systems every day, actually use these ideas to make your own agents more robust and more verifiable? The good news is you don't need to go out and build a full ASI-Evolve system to get the benefits. You can just start by applying its principles. Look for ways to automate more of your design and testing loop. Start systematically distilling your experiment logs into a knowledge base your team can actually reuse. And remember to augment your team's expertise. They're human priors, instead of just relying on random shots in the dark. Really, the big goal here is to create these closed-loop systems where every result is tracked and analyzed to inform what you do next. That's the path to building truly verifiable and robust AI. And this quote from the paper just sums it all up perfectly. This isn't just a small improvement in one little area. It is the first time that a single, unified framework has been proven to drive discovery across all the core pillars of AI development: the data we use, the architectures we design, and the algorithms that do the learning. Which brings us right back to where we started. It seems the answer is a resounding yes. AI can accelerate the development of AI. And that leaves us with an even bigger question to chew on. If the very process of innovation can be automated and sped up, what on earth does the future of discovery itself even look like?
Thanks for watching.